The first one is that building and distributing artifacts of different applications was made easier with Docker. So we are working with just one type of artifact, which is Docker image, instead of having different types of artifacts, like jar and war for Java, and zip and tar for different applications. So essentially, we're just building Docker images from these applications and not the zip artifacts or tar artifacts. And this means that there is no need for repositories, like artifact repositories that support multiple different artifact types. We just need a repository that supports Docker images. Another advantage is also that you don't need to move multiple files around to get them to server, like tar file and package.json or config file. No need to even zip the code. You can simply copy everything into Docker image file system and then run it from the Docker image. Additional advantage is, again, you don't need to install dependencies directly on the server. You can execute the install command inside the Docker image. So when the Docker container starts, from that, based on that image, the npm install will be executed. So what I mentioned in the JavaScript build tools and package manager part, that it's very unstandardized and you can do it in lots of different ways. Docker makes it a little bit easier to consolidate it, because at least now you don't need a zip file and a separate package.json. You can do it all in one artifact, which is Docker image, which is another point that Docker image is also an artifact, means that it is alternative to all the other artifact types. And instead of each application having its own artifact type, we kind of consolidate it and make it a universal artifact, no matter which technology you're developing the application with. Another advantage, again, with Docker is that you don't need to execute npm start or java-jar on the server in order to start the application. So that also means that you don't need to install npm or Java on the servers. You can execute them all in the image, and you can even pass in environmental variables that you need and define them inside the image. So again, less working with the specific tools, but rather working with Docker for all the different applications. Note here a difference again between Java and JavaScript applications. As I said, you don't have to create zip or tar files anymore when you have Docker images, because you can just copy the JavaScript files directly into Docker image. However, you still need to build the application. So for example, using Webpack, transpile it, compress it, minify it, and so on. Or in case of Java, create a jar file or war file, and then using those build files, you can actually create a Docker image out of it. So you still have to do that step. So the difference here is what happens once you build the artifact, Java jar, or build the JavaScript application using Webpack. It doesn't go straight to the artifact repository or the server, but rather gets packaged into Docker image, and that's what we're then distributing to start the application. And that makes the whole logistics and moving around that application, release, and running that application way easier. So this is an example Docker file that actually packages the JavaScript application, Node.js application. And here you see we just copy everything that is in the application to inside the container file system, in the image, and also inside the container, then we do npm install, and then we execute node command to start the server.js. So we don't create a zip file or tar file or move around package.json and the application code separately. We can do all of those in one setup, including the npm install, where the dependencies get installed, and just define all of that in Docker file. Don't worry if you don't understand the syntax for now. We're going to get to the Docker module part, where we will learn all of this syntax and all these steps in detail. This is just for an overview to understand how Docker file could look like for a JavaScript application. And this will be an example of a Java application where instead of copying the Java files to the image, we'll have to build the application first. Outside of the Docker image, obviously, we have to execute either Gradle or Maven command to build the application into a jar file. And then once we have the jar file available, we are copying that jar file to Docker container file system, to the Docker image. And now inside the container, we'll have the jar file available, and we can start the application inside the container using Java command, java -jar, and the jar file name. Of course, we will learn Docker in the later module where we will build Docker images from our applications, but this is just as a reference so you can directly compare the build tools and how Docker actually made some of this process easier.